Now that we've had a lot to say about parallel lines, we're actually going to move in the reverse direction now and talk about how can I prove that lines are parallel. So the first theorem that we're going to take a look at has to do with alternate interior angles. And so before, we were able to say that if lines are parallel, then the alternate interior angles will be congruent. But it's actually the reverse of that, or otherwise known as the converse of that, will be true as well. So this is called the alternate interior angle converse theorem. And so, as we know, what converses are in general is that if I have a statement that says if P, then Q, the converse of that is if Q, then P. And the interesting thing is that doesn't always happen to be the case. This is one of the situations where it is, though, where we had the initial statement that if the lines are parallel, then the alternate interior angles are congruent. But now we're going to prove that if the alternate interior angles are congruent, the lines will be parallel. So that's exactly what my statement is. So if the alternate interior angles are congruent, then the lines are parallel. I'll just finish it out here. Okay, so what this all hinges on, what we're going to see here in a second, is it hinges on me using, a very similar postulate to what I had when I was using parallel lines, and that would be the corresponding angle converse. So to prove this, we will go ahead and make a diagram here. So here's my diagram. I'm going to draw two lines that look to be parallel, but we don't know what they are yet. They're intersected by a transversal, and we will name all these P and Q and T, and then we'll label some angles. So 1, 2, 3, 4, 5, 6, 7, and 8. And so what I'm trying to prove is that given that the alternate interior angles are congruent, so I can pick any of these, so either 4 and 6 or 5 and 3. Let's go with 4 and 6. If 4 is congruent to 6, then what I'm trying to prove is that P and Q will be parallel. So we'll go ahead and knock this out. Statement number 1 is just that angle 4 is congruent to angle 6. That was given to us. Okay, so before we get started, let's think about where we're going with this. So as of right now, I only have one postulate that I'm going to be able to use, and that postulate is the corresponding angle converse. It says that if the corresponding angles are congruent, then the lines are parallel. So basically what I need to do is somehow use the fact that angle 4, different color, angle 4 and angle 6 are congruent to each other, that I will end up knowing that there's a corresponding pair of angles that are congruent. And so what I'm seeing here is that if I know that 4 and 6 are congruent, I can link 2 with 4 because they're vertical angles, and then I can end up linking 2 with 6, be able to use my corresponding angle converse. So that's exactly what I'm going to do. So I'm going to start by saying that angle 4 and, oh no, I switched reds. Angle 2 are vertical. This will be assumed from diagram, not given. And then I will, of course, immediately say that angle 4 is congruent to angle 2. This will be my vertical angle theorem. It says that if two angles are vertical, then they are congruent. And that comes from statement 2. All right. Then, since I know that 4 and 2 are congruent, I was given that 4 and 6 are congruent, I can link these two together. I can say that angle 2 is congruent to angle 6, and this is by the transitive property. And just like that, I'm pretty much done, because after I use the transitive property, linking together statements, let's see, 1 and 3, what I immediately know is that angle 2 and angle 6 are corresponding angles, which means that statement 5 P will be parallel to Q. And so just like before, I needed this one starting point. I needed to have at least one postulate to be able to connect these things together. And so I'm using the corresponding angle postulate that says that if the corresponding angles are congruent, then the lines are parallel. And so this will be a common strategy that we're going to employ now when I prove each of these theorems, each of these converse theorems, is that I'm basically trying to get back to corresponding angles congruent. If I can show those corresponding angles congruent, then I'll have enough to say the lines are parallel. So this proof was pretty straightforward and was the first one in our set here of converse theorems. But yes, whenever the alternate interior angles are congruent, the lines will always be parallel.